Hello, guys. Welcome to our first RUSEC workshop for 2025. My name's Ryan. I'm the vice president of RUSEC for this year. We also have our president here, Ria, in case you guys weren't here at our first general meeting. Um, for all you guys on the Zoom who just joined in, as well as people that just got here, please check in with the QR code that we have over here. Uh, we'll periodically come back to it in case anyone joins in and just misses it. If you guys have any specific questions on the Zoom, you guys can ask them in the chat during the whole presentation, as well as either like raise your hand or whatever, normal Zoom stuff. As well as anyone in the room, if you guys have any questions, you can stop me anytime. Just raise your hand or even shout out. Just ask the questions you have during the presentation. Um, Today's workshop, we're going to go over virtual machines, what they are, what they're about, why they're so crucial for us in cybersecurity, especially at a college, as well as just in general what virtual machines are about. So for the overview for the presentation specifically, we're going to go over the foundations for virtual machines. So basically, like I said, what they are, the history behind them, how the idea of them came about. We're also going to go over how, excuse me, virtual machines work. So like what is a hypervisor? What is virtualization in general? And then we have a whole specific subtopic as well on hypervisors in general because they're a very complex topic and they get very complicated. And then at the end, we'll do the importance of virtual machines and cybersecurity, which is probably our biggest section with most things. We'll also be doing a demo so you guys can get involved as well as figure out how to set up a virtual machine yourselves. Um, for anybody who to gauge the room, just so I know like what we're working with here, so I know how to pace this presentation. Show of hands, how many of y'all actually know what a virtual machine is, like just in general? Okay. Uh, how many of you guys like think you could define a virtual machine of the people that know what a virtual machine is? Okay. With that being said, since half the room kind of knows what a virtual machine is, I'll kind of speed through the stuff of just like understanding the basics of it a little bit more. But going into the in-depth of just understanding them, I'll make sure to uh, specifically go into that topic pretty well. All right, so also to give a disclaimer, just because this is one of our first presentations here at RUSEC, uh, I'm not teaching you guys how to evade law enforcement. I'm also not going to be teaching you everything we do in this club, as well as especially with virtual machines, how to like conduct actual illicit activities. Most of the things we do in the club, as well as the activities we do, they're completely simulations. We're not trying to do anything illegal, and we definitely advocate that in this club. So what you do on your virtual machines outside of this, club, once you get them set up, that's your own risk. We are not liable if you do anything illegal. We're not going to advise you guys to do anything illegal either. So, I mean, I assume all you guys are college students. You guys know what to do and what not to do. Just don't do something stupid. All right, so foundations for virtual machines. So, the basics. What is a virtual machine? In its basic definition, a virtual machine is the emulation of a physical machine. But what does this really mean deep down? Because I mean that definition it can mean whatever to someone who doesn't understand. So I felt this laser pointer. You don't have it? Okay. I'll just use my finger. So in its simplicity, right? You take a server, computer, any physical hardware, right? Thank you. So you take any physical hardware, right? Like even my laptop, any of your guys' laptops, and you can turn it into multiple different virtual computers with their own operating systems that can conduct their own processes. So basically, any physical computer can be utilized to run software, virtual machine specifically, and to behave like a normal computer. And that's the whole premise of what a virtual machine is, especially in the usage that we're going to do in this club specifically. All right, so the idea in general of how virtual machines came about, they came about as a time-sharing solution from IBM in the early 1970s. IBM just came up with the idea because they were like, okay, we have data and we have lots of computers, lots of things we need to interact with the data we're utilizing. How can we take one really big computer and allow it to run multiple different processes together with other people utilizing it to be able to analyze that data? Because I mean, when you have a very a room, like a server that's the size of a room, it's kind of hard to just have one person working on it. So their whole idea was just to come up with a solution to be able to handle multiple computers. Um, and so basically, the idea of time sharing is the shared usage of computer resources among many users to increase efficiency as well as utilize all the computer's resources without like wasting money and effort. Um, with how much resources servers have now, insane amounts. I mean, your own personal computers are way more powerful than those servers, even going back to like the 1990s. Virtualization became much more of a commonplace strategy throughout data centers and many businesses alike. And it has evolved heavily since like its introduction in the 70s. But the idea has pretty much always been the same, the process of how it goes about. All right, so now into how virtual machines work. Like I said, if you guys have any questions during the whole presentation, just raise your hand. You can stop me. I'll try to guide you guys along with everything. Um, so how virtual machines work? There's two types of virtual machines. You could do what's known as a process virtual machine or a full system virtual machine. Um, a process virtual machine is only handles one process at a time to run on a host machine, and pretty much just runs that process and handles all that virtually. Um, it masks it under an underlying hardware or operating system that you don't see on your physical computer to run the process, regardless of what the host platform is. Some examples of this, not really focused on that much in this club, but I thought I'd give it, is the Java virtual machine, the .NET framework, and Parrot virtual machines. Again, we don't really cover that type of virtual machine that much, but I thought I'd at least mention it in case any of y'all were interested in learning what a process VM is. System VMs, this is more of the stuff we're focused on in this club. You take a full virtualization of a physical machine and use a hypervisor to analyze those, like your physical machine's resources to create a full system virtual machine. Examples of services that do this would be VMware, VirtualBox, which our demo is going to be on VirtualBox, um, Hyper-V, which is Microsoft's version. I personally haven't worked with it, but I've seen it used. And then Zen, which I've never heard of, but thought I'd at least list it. Um, so there's many modern day applications for virtual machines. I thought I'd also list an image of just different Linux distributions because it can show the wide range of uses for Linux as well as how much they're used in virtual machines. Um, Initially, it was more just for IT teams to manage computer resources and efficiency. Uh, Really, that just became the situation because, like I said, computers at that point were really big, really complex, and when you had a lot of processes running on them to try to analyze data, it's kind of hard for just like one person to be doing that. So they wanted to be able to make it so where multiple people can do that at once. Uh, Risky tasks also should not be performed on a local machine. VMs can be easily terminated and like killed to make sure that there's no issue with them because they're separate from your actual physical layer. We'll go more into this later because that is very relevant to why we use them in cybersecurity, one of the many reasons. Um, and then also, virtual machines allow for cloud-based virtual desktops wherever convenient. So again, it comes down to also a convenience thing. I mean, being able to just really quickly boot up and change an operating system if you need to use resources from a different, uh, operating system is very nice, and so that allows you to do so. And then data center resource management. Again, going back to the data center point, when you have so much data, you just using a virtual machine is so much easier to be able to utilize and analyze everything going on. All right, so now going into the hypervisor section. This section is, I'd say, more complex than we would need to go over, but I will cover it as well just so everyone can get the basic understanding of what a hypervisor is. Okay, so what are hypervisors in general? A base definition is that a hypervisor is a software layer that handles the communication and translation of like your computer's resources into be able to create a virtual machine. That's basic definition. I'm not in this for the scope of this presentation. I'm not going into the deep layers of how hypervisors work. That would be like a whole class at Rutgers. We don't got time for that, and that's really not useful. But Basically, multiple virtual machines get the physical machine's resources through that communication with the hypervisor. Um, the hypervisor also is what handles the simulation of virtual hardware components when you're actually creating a virtual machine uh, through your local host machine. The purpose of a hypervisor is that it improves speed, versatility, mobility, and efficiency. Again, going back to the whole idea of like you can get a system up and running very quickly, and if you need to be able to test something and use something through another operating system, that key thing there is where that comes in, and that's why we have something like a hypervisor to handle that. So there's two types of hypervisors. We have type one and type two. Um, Type one is built onto the host machine, so actually in your computer and like not as a software. The virtual machine interacts directly with the host without usage of other softwares, as mentioned. Uh, and these can only be used for virtualization, not the idea of being able to do multiple different like tasks. Examples of these was what we mentioned earlier with Hyper-V. Microsoft's Hyper-V does that, as well as Citrix Hypervisor, which I've never worked with that, but I've heard of it. Um, and then we have type 2 hypervisors. These are the type that are extremely crucial. These are the ones that we'd be using specifically in this club. Um, and those type of hypervisors are a software application that runs on the host operating system, so physically on your machine, whether you're using Mac OS, Windows, whatever. Even if you're using Linux, you can still run one. And they use the software layer to relay the request to the host and pass the resources back to back. So it's basically a handshake through the software that allows the hypervisor to interact with your machine. Uh, because of this extra layer, it takes a lot more time to handle a request. So if your whole goal is just virtualization, type ones would actually be better, especially if you're like in a data center or a server and you're trying to just save resources. You'd probably want to use that route. But in the case, like I said, of this club where we have full laptops, full computers that are ourselves, we can use type two and it won't affect us that much. And examples of those would be VMware or VirtualBox. Those are two services that are hosted that are type 2 hypervisors that you can utilize to run virtual machines through. Okay, so now we're going to go into the stuff that actually kind of matters for this club, virtual machines and cyber security and what they're all about. So why is it important for us in this club specifically to use virtual machines? Ease of use and convenience like allows us to run these virtual machines and practice with different operating systems as well as learn different skills revolving around that. Um, like I said, allows us to test things in a very simple manner. You can get an operating system running in like literally minutes and just test whatever you need to test if you find something new or find something interesting you want to learn. So it's a very good learning resource with something like that. Um, it also allows us to test different types of attacks with less risk of a threat actor getting privilege escalation or causing harm to your physical computer. If any of those terms are confusing, you can just ask and I'll explain them. But there's an asterisk there, and that asterisk is that there's what's known as a virtual machine escape attack, and that can happen where a threat actor intentionally knows you're using a virtual machine. They create a type of malware to be able to get from your virtual machine back onto your physical machine. It's very hard to do. There's not many report cases, at least to my knowledge, of those types of attacks actually happening and being successful. However, that is something to consider if you're going to, on your personal computer, test different things through a virtual machine. Um, but they also allow us to use many tools at our disposal rapidly to do different types of ethical hacking, as well as find information related to cyber threats in general. Yeah.
On top of this, you could also simulate malware using a virtual machine. Never do it on your actual machine. A virtual machine is the best way to simulate malware or reverse engineer malware as well.
Yes. Going on with that second bullet, yes. Don't do it on your own machine. Do it only through a virtual machine. And even then, be careful. I'm going to mention something as well later in this presentation called AnyRun. I'd say if you don't know what's going on and you're hesitant about like running like something you don't know on your own computer, you can use a resource like AnyRun, and that doesn't even have any interaction with you. Yes, what's up? Yeah. So threat actor is a cybersecurity term. I'm just going to lay this out now. Cybersecurity has a lot of terms, and we're probably going to slowly integrate them into the club so people can learn what they are. A threat actor is pretty much anybody who is doing unethical hacking. It could be a nation like, like North Korea, China, etc., India, whatever. That would be known as what's known as a nation state actor. Uh, or it could just be your local person. We might have a workshop specifically going over different types of threat actors, but in general, a threat actor is someone who's just trying to attack a system. Could be, like I said, anyone in a business who just like has something that they're not happy about. A good example yesterday was the Mirai botnet attack. The guy who did that attack was a Rutgers student. They're still a threat actor, just a one inside the organization. Um, but yeah, there's many different types of threat actors. But yeah, just as a basic definition, a threat actor is someone who's just trying to cause threat and harm to a system. A privilege escalation, that is a term specifically used in cybersecurity to uh, it basically it's how hackers are able to get more resources and be able to do more on your computer. The best example I'll give is in Linux. There's something known as root. That is the base user on a Linux operating system, and that user has access to all types of files, all types of services, everything that can be done on a computer. And there's also just no regular base users that you can set up through Linux. Through Windows, it's um what is it? It'd be administrator. Yeah. So it'd be administrator. And then you have administration privileges, which some things you're allowed to run if you have administration privileges, whereas others you cannot. It's to help protect an operating system and basically prevent it from uh anyone being able to do whatever they want. You can set up users to specifically have certain permissions. Um, Privilege escalation is a type of attack where users are able to completely attack like they attack a system and they're able to change their privileges from like a base user to be able to become an administrator or a root user or whatever you uh have been to be able to do more on a machine to cause problems. So yeah, that's just a base definition of those terms. All right. So applications for VMs for us in competitions. Very important for us to practice. Literally, I'm going to be honest with you guys. Like I said, I joined this club last year. I can't tell you if there was a single week last week when I was like involved with this club where I didn't use a virtual machine. Um, Whether it be through my own computer or using a service like Proxmox, which we might go into a little bit later in the club. I was pretty much always using a virtual machine to either do a task or learn something new. Um, and yeah, like as mentioned before, it allows our clubs to be able to just use different operating systems, navigate them, understand them. And it's especially useful if there's something you don't know about beforehand and we're going to a competition. Like, let's say something like an operating system like Fedora, right? Let's say you've never used Fedora before. You don't know how it works. You don't understand it. You've never even seen it before and you just want to get comfortable with it. Something like this is a good resource because then if you know you have to run a Fedora operating system in a competition, you'll know exactly what to do because you'll be able to practice with it way ahead of time. And yeah, like I said, it gets us to have real hands-on experience with competitions because usually something like CCDC, in that competition, we'll get a packet that tells us specifically what types of computers are being used on it. And so we can just be able to set things up virtually and be able to, figure out what types of hacks are possible and whatnot on those operating systems. So yeah, very nice tool to be able to learn just anything. Yeah.
I just want to add on, if you guys know of Hack the Box, the best way to practice using Hack the Box is to use a virtual machine. Using your own personal laptop can be a bit tricky because you have to connect to a VPN for Hack the Box, which we will go over in a few weeks. But VMs are quite important also for just practicing as well, for learning more cyber knowledge.
Yeah, for sure. Definitely for Hack the Box. When I was using Hack the Box myself last year, I used exclusively Linux. Also, a lot of the commands they're going to try to teach you through like the introductory ones are specifically Linux commands. So being able to just get in a Linux machine, learn the terminal, and like understand the terminology and how things work is really going to be best for especially cybersecurity in general. Um, so this is more now just going on to right before the demo, just so anyone can figure out what VirtualBox is about. Oracle created VirtualBox. I had actually a slide, that history slide was actually from Oracle, funnily enough. They created VirtualBox as a Type 2 hypervisor so that host systems can run multiple operating systems and instances on a host machine without affecting their personal device. So basically, just any type of Type 2 hypervisor virtualization. Um, so the grounds for what we'll be demonstrating, and the reason we picked VirtualBox is just because it's a little bit simpler to set up, a little bit easier for people to use, and anyone who's familiar with like Java knows Oracle, so it's a company that you can just see as trustworthy. So that's why we chose that one. All right, so going now specifically into the demos. I have the link here for myself just to access easily. What I want you guys to do is on your own computers, if you guys want to follow along, or you guys can just watch. Uh, Go to VirtualBox, just their website. You literally just look up on Google VirtualBox Oracle or just like VirtualBox, and you should be able to. All right, and then you should be able to pull up this web page just for downloading VirtualBox by clicking the download link. And from there, you here is the option for the different platform packages you can install, depending on what operating system you guys are already on. If you guys are using Windows, click Windows hosts. If you guys are using Mac OS, if you're using Intel specifically, do the Intel one. If you guys are using like the new Apple Silicon chips, use that one. Yeah. Okay. Yeah, on your I don't know personally Mac OS. I couldn't tell you where to specifically go. It'd be somewhere in settings though, maybe like about in settings. Yeah. So in that case, if it's Intel, your chip, then you'd want to use the Intel host one. If you're using one of the newer MacBooks, like really recent ones, it'd probably be Apple Silicon because that's their Apple M1, M2, M3 chips, stuff like that. You want to download that link. Yep. So yeah, you'd probably be doing the Intel one. So, there is Linux distributions. It should be able to support it. I didn't double check that myself. Because I run personally Windows. If you have any problems, let me know afterwards. I can demo VMware as well. I should have mentioned that in the slides. But yeah, if anyone is uncomfortable and doesn't want to do VirtualBox, I can also show a demo on VMware because that's what I use personally. But yeah, so after that, once you click on that, it'll just literally instantly download it. You can download it wherever to your computer. And then it shouldn't take that long. It's a pretty quick download. Once you get it downloaded, I'll give you guys a couple minutes to just get it set up. Once you guys get that downloaded, though, it should pull up something like this, which just says Oracle VirtualBox Manager once you open or run the program. Yeah, I'll just give like a minute and a half. I don't think it should take that long. And even if it does, like I said, I can help demo it right after the presentation too. Shouldn't be an issue. All right, so while that's downloading or once it's already downloaded, for our first operating system, we're choosing specifically Kali Linux. Uh, Not necessarily that it needs to be Kali. A lot of Linux is Linux. You could run pretty much any Debian-based Linux and it should run. I can explain the different types later, but um, Kali Linux is the one we use because it pretty much comes with a lot of resources already pre-installed, so it makes it pretty simple, at least for cybersecurity, as it has a lot of the packages you already need pre-set up. Another option is ParrotOS. Again, if you guys want a demo, I can demo that after. But yeah, specifically to get to Kali, you're gonna go to Kali's website, which you can literally just look up Kali Linux on Google, and it should pull up the Get Kali page where you can pretty much download anything. From here, then, because we're using a virtual machine, there is the possibility if you guys didn't want to download a VirtualBox ahead of time, you could just download it as a virtual machine file. However, I don't recommend this. My experience of doing that, done it a couple times. Almost every single time it corrupted my files doing that, and I just had to reinstall it. So for simplicity's sake, that's not why we're not demoing it this time. Instead, you're going to click on this one here. It says installer images. And from here, you'll choose to download the installer with this download link here. This is what's known as a .iso file. It's how pretty much you can, like make an image for a virtual machine. If you're using Windows, you'd want to use the x86/64 version. If you're using again Apple Silicon, so any new Apple chips, Apple M1, M3, etc., you'd want to use the Apple Silicon version of it. Yeah. If you're using Mac Intel, you'd use the first one, the one I was showing initially, the x86 one. Yeah, the where the download link is right here. I can download it myself really quickly just to show it. Yeah, you just click download there, download it to wherever you need. And this file is 4 gigs, so it might take like 4 minutes to download. That's fine. I'll still go like kind of slowly and explain like kind of how to analyze VirtualBox while all that's downloading. So once you're in VirtualBox, I know it looks like a lot initially since there's just random stuff here and it's just a lot of information thrown at you. The good news is it is simpler than it's showing. I just have a virtual machine set up here already. This doesn't matter. Yours will be blank. Doesn't need any information. What you're gonna do is you're gonna click open, or not open, sorry. You're gonna click new. And then from there, you can name your virtual machine whatever. For the scenario of this, I'm just gonna name it test. Um, you can save it wherever you want on your files. That doesn't matter. That's your choice for wherever you want to like locate VirtualBox in general for the virtual machine. And here's where it matters. There's a reason I mentioned it's a .iso, and it's because of this here. It asks you to input a .iso image. And so from there, you can select your files on your computer. Again, wherever you guys download it, I'm not going to tell you where you download your files. You can select that image, and it should look something like this, saying Kali Linux 25.2 installer. You'll click on that, and then for OS, it's Linux, so you can just select Linux. OS distribution, again, we'll probably have a workshop on the different types of versions of Linux, but for the sake of now, just know it's Debian, and you're just going to select Debian as the distribution. And then the OS version is going to be a 64-bit version of Debian. That's all that needs to be known. From there, all these other options, specify virtual hardware. This is kind of relevant as this is the resources it's going to take from your computer to be able to run the virtual machine. Me personally, I have a more powerful laptop. I have a lot of memory on it already. I can pretty much do a lot, but for most people, I'd say a good like 6 to 8 gigs of memory at most is needed. I'd say even 4 you could pretty much get away with. Uh, the conversion for that, if none of you guys are like, if some of you guys aren't CS majors, is like 1,000 megs is 1 gig. So 4 gigs would be 4,000 megs. And I would say I would suggest just doing somewhere around 4 to 8. For number of CPUs, again, it depends on your specific computer. I can't tell you what your hardware is on your computer. I recommend at minimum doing 2 CPUs just so you can get multi-threaded workloads. Again, very complex topic I'm not going to get into. Just know I'd use at least 2 cores and maybe even slightly more if your computer can handle it. But just for the sake of the demo, I'll do the minimum just to show you guys what it looks like. So I'll do 4,000 and then 2 cores. Um, that all the other options, they're not needed. Just select that. That's all you need. And then at the end, it's going to ask you to specify your virtual hard disk. This is your hard drive, how much storage your computer is going to use when you run the virtual machine. Um, if you plan on running the same virtual machine like I typically do for VMware, I'd recommend giving yourself a good amount of storage just because you might download a lot of files. You might have a lot stored on your computer. So I'd keep a lot. For the sake of this demo, I'm only going to put 20 gigs. But if you do use it a lot, I'd say go somewhere even higher, maybe 40, 60 gigs. Because usually Kali takes about 16 gigs to begin with the version we did. Um, Hard disk type is just going to be a VDI, virtual box disk image. That's perfectly fine. Um, and then from there, you'll just click finish and it will create it. I'm not going to run it yet. I'm going to give you guys a minute to be able to do all that as well as if it's still downloading for you guys. But Yeah, that's how you go about just getting your virtual machine set up on VirtualBox. Yeah. What do you mean? Yeah. Well, the that's what Linux we're running, right? You need a .iso file to be able to run a virtual machine because you need to be able to download that operating system, right? The virtual machine itself is, allowing you to interact with your physical hardware to create another operating system. Normally, you wouldn't be able to do that. So you could use like other versions of Linux. You could use like Ubuntu. You could use Mint. You could use a ton of different versions, but you have to use Kali for something like this. Okay. So from the Kali website, I'll go back to it. You're gonna go to the this is literally the base platform when you like go to the website. You're gonna click installer images, and then if you're on, like I said, Windows, you use the x86/64, or even if you're just on an Intel Mac. And if you're on any new Mac, you'll use the Apple Silicon ARM64, and you'll download that installer. So good question. Also, just for everybody who is on the Zoom, we have a 40-minute limit through the college, Rutgers kind of being Rutgers. It's gonna end in 1 minute. You guys can rejoin. I'm gonna rehost the meeting again. I might have to put a new password. I'll put it in the Discord, but yeah, because I know we're gonna go over the time limit. Sorry if this seems like a lot of info I'm throwing at you guys in the beginning. It's just this is kind of like the base stuff to like be able to just like learn a lot more in cybersecurity. Like I said, if you have any questions after the meeting as well, you can come up and talk to me privately, and I'll help answer as many questions as I can. Yeah, Rutgers Wi-Fi. I mean, yeah, even if it takes that long, that's fine. You can do it like after the meeting. I'll try to, like I said, go slow with actually showing setting up Kali. I'll give it a minute just for the Zoom. I'm gonna reset the Zoom and then I'll start doing the demo of like actually setting up Kali. The recordings of the Zooms will be posted on our YouTube channel. We have to get someone to edit them first to put them together. But yes, they will be recorded and posted on our YouTube channel, not in the Discord. We might post a link in the Discord, but they won't be on the Discord.